Hello, so in today's video, we're going to look at examples of non-functions, so non-examples of functions. So what is not a function? So in the last video, we looked at what a function actually is and how we can tell if a mapping is a function, but what is not, does not count as a function. So let's just remind ourselves that these four examples that I've drew here, uh, these are examples of functions. So for example, this one here, this could be something like I don't know, f of x equals perhaps x plus 1, where x is a real number. So this is an example of a function, and and we can see that because every x value in our domain, so again, the domain is just the set of x values in which this function exists, in which we choose, which is arbitrary. So in these set of x values, we get one output. So an output, an output, an output, one unique output. Every input gives you one unique output. So this is called a function, and in fact, this function here is a one-to-one function. And we looked at this in the previous video. So one-to-one functions, for every output, there is one unique input. So this is a one-to-one mapping, and we can tell that by the horizontal line test. Just draw a horizontal line across. There's always one point of intersection, so it's called a one-to-one mapping. So this one is one-to-one. Let's just make a note of that this is a one-to-one function. Okay, great. So that's that one. Now, how about this one? Again, this is a function, and we can tell that because every input gives us one output. And in fact, this could be something like, for example, I don't know, f of x equals, let's just say x minus 1 times x minus 5 times x plus 5. So it could be something like that, a cubic graph like that with your minus 5 there, your 1 there, and your 5 there, just by looking at these factors and determining the roots using the factor theorem, essentially. So yeah, we've got this cubic graph, and again, it is a function because again, every input you put in, you get one unique, well, not unique, but you get one output. So for every input, you get one output, not two numbers, not three numbers. You get one number for every input, and this is now a many to one mapping instead of a one-to-one mapping, because for multiple x values, so for example, this x value, this x value, and this x value, you get one output. So this is a many to one mapping. So the key thing is that functions always map to one thing, so one-to-one or many-to-one, and this here would be a many-to-one function using the horizontal line test. So many-to-one function because many inputs can give you the same output. Okay, great. And now how about this one down here? Again, we can see this is actually a one-to-one mapping. So every horizontal line you draw, you've got one point of intersection. This would be a one-to-one mapping. So this again is a function. And this function could perhaps be something like, I don't know, it could be f of x equals the square root of x, and defined for x being bigger than 0, for example. And again, I should really put the domain up here. So let's just say the domain for this one is x in the real numbers, every real number on the number line. But in this case, you can't take a square root of a negative number in when you deal with real maths, with real numbers. So therefore, this would be our domain here. We can choose a domain like that. We can choose x is bigger than 1 or x is bigger than 2 too. We can choose any domain we like as long as x is a positive number in this case. And again, using our horizontal line test, it's a one-to-one mapping. So this is definitely a function, a one-to-one function. And the last one, so as you can probably guess, this is actually, again, a many-to-one function because we've got multiple points of intersection using our horizontal line. And that gives us, yeah, so multiple x values, multiple inputs can give you the same output. And we always get one output again. So every input, you get one output. You don't get multiple outputs. So therefore, yeah, this is a function, and it's a many-to-one function again. So it's a many-to-one. And this function here could be something like a modulus function. So it could be something like f of x equals the modulus of, let's just say, x minus 1, for example. That looks about reasonable. So yeah, we've looked at these modulus functions in previous videos, so you can check out the videos I've done on that if you're a bit unsure on what these modulus functions are. So yeah, that's again we should put the domain in here. So x is a real number. So yeah, that would be These are all examples of functions. However, these two examples here are not functions. So why are they not functions? So let's think about it. So we've got a mapping here. So I mean, whether it's a function or not, these are still called mappings. These are all called maps. So these are all, let's just make a note of this here. So these are all maps. So functions are examples of maps, and this is still these are still maps too. They map one number onto they map numbers onto numbers. That's what a map basically is. It's a function or sorry, a map which takes one number, maps it onto other numbers. So we've got a mapping here, but now if we pick an x coordinate here, if we pick an input on the x-axis, we get two outputs out. So we get an output out there, an output out there. That's not a function. We're not allowed to get two outputs with functions. We only get one output. Now with this one, again, we get two outputs. So for every input here, we're getting out two outputs. This is not what we want. We don't want two outputs on the y-axis. We must have one output. So for every x, we must get one output, not two outputs like this here. And a similar thing here, again, we're getting, so for every x coordinate, every input, you get two outputs on our y-axis like that, and that's not allowed. So these are not functions, and you can test again whether a function is not a function by the vertical line test this time. So what we can do is just draw in a vertical line like that. Do we have more than one point of intersection? Yes, we do. So this is not a function. These are not functions. So the vertical line test, so vertical line test. So draw a vertical line onto your graph if there is more than one point of intersection, then that implies not a function. So not a function. So like these ones here. And I mean, if we do the vertical line test for these ones back here, again, vertical line, vertical line, vertical line, vertical line, vertical, vertical, vertical line, vertical, vertical, vertical line. We've only got 1 point of intersection with each vertical line. These are all functions. So that's what a function gives you. It gives you one output. Put a number in, put an input in, you get an output, one output. Put an input in with these, you're getting two outputs. So this is, yeah, this is not a function. These aren't functions here. So I mean, this one here, for example, could be something like the graph y equals plus or minus the square root of x. Again, this is not a function. You're getting plus a positive output and a negative output. This doesn't work. Now this here could be something like, so it could be something like y equals plus or minus the square root of, I don't know, let's just say 25 minus x squared. It could be something like that. So basically a circle or an oval equation if you want to put like coefficients there, for example. But I mean the general shape is kind of the same kind of thing. Again, this is not a function. Now, in fact, the first one here, this first mapping, this is called a one-to-many mapping. This is a one-to-many because one input is giving you multiple outputs. So one input, multiple outputs. This one over here is called a many-to-many mapping, many-to-many, because multiple x coordinates, multiple inputs are actually giving you multiple outputs on your y-axis. So kind of like this rectangular shape. So multiple inputs give you multiple outputs. This is a many-to-many mapping. That's called a many-to-many mapping. Okay, so that's these are non-functions then. So let's just say, oh yeah, a key reminder as well, actually. So for a function to be well defined, remember we need to give the domain. So I've done some examples here actually. So if f of x equals x squared, I mean that's a function. We know that's a function. Now this is not well defined. So well defined just means you've not defined the thing well enough. It's not true until you specify what the x values are that you're inputting into your function. Well, how can you have a function unless you know what x values you're allowed to put in? So with this example too, we've specified that x must be a bigger number than 0. So we say here's a function, and I'm telling you directly that x is bigger than 0. We've defined it. We've given the function a definition because we specified this function works when x is greater than 0. Again, these domains are arbitrary. So the domain is something we choose. So it's arbitrary. Okay, so then again, this third example here, fx equals x squared. But this time we've said, okay, this we specify that this function exists only for integers. So again, remember this set is the set of integers, so the set of whole numbers. And this is well defined, and this is well defined, but this is not. We've got to specify the domain, and your questions in your exam will specify the domain. Otherwise, it's not a well-defined function. But a key summary of everything. So yeah, functions are either one-to-one or many-to-one mappings, right? That's what functions are. And you can test whether a function is a function by the vertical line test. So draw your vertical line in on your graphs. Let's say you got a graph like that. Draw a vertical line, one point of intersection. This is a function. However, if you've got something like something random like this, draw your vertical line in. You've got multiple points of intersection here. This is not a function, because you've got multiple outputs when you're not allowed that. So yeah, one to many or many to one mappings is not, they're not functions, so they're not functions. And functions must have a domain in order to be well defined. So again, domain is just, for example, this there, these are domains. So domains again just mean the set. So set of x, so set of inputs, I should really say set of inputs in which you choose to define your function, which you choose to define your function. If I can just fit that in at the bottom there. So that's what a domain is, just a reminder of that. Yeah, so this is just a summary of what a function is and what a function is not allowed to be, and the fact that you need to specify a domain, or the question in the exam will specify a domain in order to well define your function.